let's do a serious one, right? We are in the math class. Let's plot. I'm thinking now plotting the sine function, right? Sine function. We have the canvas, and starting somewhere in the middle of the canvas, we want to do the sine function. Oops, I didn't, should touch the bottom here. So, you know, we know already that the canvas has 800 pixels on horizontal and has 600 pixels on vertical. So we need to somehow map. So when we'll do it in degrees, we want to map all the 0 to 360 degrees into 0 to 800 pixels on horizontal, right? And when we do it on vertical, we want to go from 0 to 600 pixels basically and map it to values of the functions which are basically they vary between -1 and 1, so between -1 and 1 kind of, right? So let's focus on this horizontal thing. So the question is, if we split the entire interval of 800 pixel in 360 smaller intervals, what will be the actual size of that thing here? So but this is pretty easy to calculate actually. So if we have from 0 to 360 degree here, so basically here we can put x and we find out it's 800 by 360, the size here, right? So it's a simple rule. So that size here, it's 800 by 360, right? So we can right? Yeah, should be right. So so let's basically this is, so basically let's name this one, let's say this is the distance, this whatever variable d, this is the distance. And then what we want to do, we want to do a for to go to all the angles from 0 to 360, and then for each angle we'll figure out what is the value of the sinus in that point. And actually this line is pretty difficult to draw, so what we're gonna draw, some vertical lines like that, right? So this will just go like this, because these lines are much easier to draw, at least at this current moment. And I saw this kind of representation on the P5JS website some time ago. On the CodeGrappy website, there is a representation where sinus is drawn like a line. On the P5JS website, there is drawn with this line. So we're gonna take this approach basically. And the reason I'm saying it's much easier is because we draw as many vertical lines as angles. So basically we draw 360 vertical lines, right? One for each angle. And the height of a line is basically nothing else than well, sinus of an angle in that point. And because, well, it's not just sinus of an angle. Yes, that should be the value, but sinus of an angle is between -1 and 1. So you know what, we're gonna multiply it by 300 here, which is half of the screen, times 300, just because we want to stretch that -1 and 1 interval and stretch the interval on the entire canvas, right? So if we stretch it, basically if we multiply by 300, we should get the upper part, and then it should go the bottom part as well. Right, so I think we have all the elements in order. We are missing one thing that I'm gonna show you today, is basically how we calculate the sinus of a value of an angle. We never touched this one. It's a simple mathematical function, but you know, you'll get it in a second. So let's start by that, defining that, what is the space there, although we don't need it at this moment. Yeah, you know, let's have it here, it doesn't hurt. So this one we said it's 800 divided by 360. So these lines will be drawn at this interval apart, basically. And now let's loop. And you know what? Although the lesson is about nested loops, this exercise is actually simpler. It's just a single for loop. We just loop once through the angles. Perhaps we should have done it yesterday, but you know what? It's still in the same bucket with for loops. So I hope it still fits with the lesson. So let's choose a variable. We can name it angle, right? So angle goes from 0, angle is less than 360, and angle plus plus. We iterate through all the angles here, right? And then we need to basically find out the value for an angle. Let's say we take this in a variable, and as I said, it's, look here, this is the new thing. It's, we use the function sin, and we put here the angle. So we are taking the value here in a variable, right? Probably won't be enough because we expect sine to return between -1 and 1, right? So if we're gonna start to plot the height of that line as being this one, those lines will be tiny, but we can leave like that, and then we'll magnify them. So let's leave them like that. The question is, what will be the x for the lines? And the x for the lines is pretty easy calculated. It's based on the angle, right? So it goes from 0 to 360. So it's angle multiply by this constant that we name it here d, right? It's exactly like with the other things that we placed on the horizontal or vertical before. So we just paste them apart. And the y, well, the y can start in the middle of the screen because we want to go up and down. So y it's just a constant, is 300, right? So at this point we have the value, which will be the height of the line. We have x and y. Let's draw the lines. Line, start x and y, which is basically on the horizontal line, and now they need to go up and down. So x will remain the same, but y will be added with the value. So this being the height of the line, is basically we're adding with this value, and probably will not look right. Again, this one should be between -1 and 1. Let's run it anyway. Yeah, I think if I'm squinting into the here really closely, I think I see a sine function, but I think it's because of the multiplication. So let's just multiply it with 300 like we said, so we can basically just make this, let's put the comment on top. So, sine returns values, and we can say here we multiply with 300 to stretch on the entire screen, or vertical, right? So let's see. Yep, there is one problem. If we go on Wikipedia, sine again, if we see that sinus, it goes up and down. Ours goes down and up, and there's simple fix. But let me show you what's going on here. If you know, in math, regular Cartesian system has x going to the right and y goes up, right? In our system and on computers, not only in CodeGapi, but in not only in all the other graphical environments, on virtually, not all, I should not say all, in virtually all of them, or most of them, x is still going like that, which is fine, but y goes down, right? So, but on the other hand, sine is a mathematical function, so it returns a mathematically accurate result. But when we plot them on a coordinate system that is turned upside down. So here, instead of adding the value, I think if we're subtracting, we should complement to that thing. Yeah, and they just go in the normal way. All right, so this is the okay, this is a sine with lines. This is a sine graph with lines. and it's a single 4. And yeah, these lines are so squished together because here we're divided 800 by 360, so they're very, very closely squished together. You know, if we don't step the angle so often, if we do the angle plus equal 5, maybe not go from angle to angle, yeah, we can have, you know, we represent fewer angles on the screen, so lines look a little bit more spaced out. What else we can do? Yeah, why not go beyond 360, right? So let's see the full sine effect, because this is a function that repeats itself. So instead of going to 360 here, why not go to 720? So we double it. And I think we should do the same here, because yeah, and see, the sinus repeats itself. So perhaps we should have a constant n, how many iterations we want, and then here it's 360 times n. We divide by these guys, and this is 360 times n. So for one should be the same as, yeah, like that. We try with 2. If we try with 3, yeah, we can see. And now we elongate it a lot. So just remember, at this scale, here is 0, here is 1, and here at the bottom is -1. So it's not on the scale on horizontal and vertical. And but yeah, other than that, it looks pretty correct. So we have the sine function. I'm gonna save it here. Perhaps I should leave this as an exercise to you. I'll not share it on the chat, but should be pretty easy to reproduce it. Again, there is also another sine example, but it's more complicated on the CodeGuppy website. So there is a simple one, like something like this one on P5 website, and but this is our approach to the exercise.